Hi guys, tonight we are going somewhere that no map has ever shown. A place that exists only in deep time, buried beneath the bedrock of every continent you have ever stood on. Tonight, we are going back. Back 250 million years. Back to a world where there were no oceans dividing us, no Atlantic, no Indian Ocean, no Pacific as we know it. Just one vast, silent land and one endless sea wrapped around it like a dark, breathing shroud. Tonight, we spend a day on Pangea. Before you settle in, take a moment to like the video and subscribe if you're enjoying these calm documentaries. And I'd love to know where you're listening from tonight, so feel free to leave a comment. Close your eyes and let yourself drift backward through time. Not through years, but through millions of them. Past the age of the dinosaurs. Past the first flowering plants. Past the first forests. Past the age of great fishes. Past fish with fingers pulling themselves onto mud flats for the very first time. Past the first creatures that dared to breathe air. Keep going. You are moving through time the way a deep-sea current moves, slowly, deliberately, carrying everything that has ever lived in its cold embrace. And then, you arrive. It is dawn on Pangea. The sky above you is the same sky, the same pale gray of every morning before the sun clears the horizon. But the air is different here. It is denser, warmer. It carries a weight that your lungs are not entirely used to. Higher concentrations of carbon dioxide, just enough to make the world feel thick, close, and heavy with a kind of raw aliveness that the modern world has spread thinner across its wider surface. And the land around you stretches in every direction without a visible edge. No coastline within sight, no ocean, just land, wide, ancient, and impossibly red. Much of Pangea's interior is red. Red because the soils are old. Old in a way that the word old fails to capture. These soils have been baking under the sun for geological epochs. The iron in them has oxidized, has rusted, and so the whole interior of this supercontinent glows in the low morning light like a slow ember. Amber and crimson and the deep rust color of dried blood. In some places the red is interrupted by pale white patches, evaporate minerals, the dried residue of ancient inland seas that came and went in cycles too long for any individual creature to have witnessed. Salt flats, gypsum plains, stretches of almost lunar paleness in the otherwise red-amber landscape. As there is a wind this morning, slow and dry. It moves across the flat plains of what will one day become the American Midwest, carrying the particles of dust that have traveled thousands of kilometers from the interior highlands. This is a world of vast, almost unimaginable distances. You could walk for months across Pangea and never reach the sea. That sea, the one great ocean, has a name. Scientists call it Panthalassa. It means all sea, and it is the largest ocean that has ever existed on this planet. A body of water so vast it covers more than half of the Earth's entire surface. If you could look down from space at Pangea, you would see one brown and red mass of land sitting in the lower portion of your view, and then the rest of the world, water. Deep, ancient, impossibly blue water, stretching to the horizon in every direction. But you are not near that ocean this morning. You are somewhere in the interior. Perhaps in the region that will one day be torn apart and scattered, pieces becoming North America, Europe, Africa, Antarctica. The bones of every continent you know are here, pressed together, seamless as though the idea of separation has not yet occurred to the earth. The first light touches the sky. It does not come all at once. It arrives the way all true dawns arrive, slowly, in stages, as though the world is being remembered rather than revealed. First, a lightening of the eastern horizon from black to dark blue. Then, a faint warmth of color at the very edge, a thread of amber that thickens by degrees. And in that light, you hear something, a sound from across the plains, low, rhythmic, almost like breathing. It is not the wind. It is not a river. It is something alive, something large and slow and utterly unhurried, moving through the low fern scrub at the edge of the horizon. You stand very still and listen. The sound continues. A low dragging, a soft percussion of footfall on dry soil. Then another. Then many, overlapping, becoming a kind of slow, patient percussion. A herd moving at dawn. Welcome to the morning of the world. We are in the early Triassic period. The world is still being rebuilt after the catastrophe. The Permian extinction, the event that scientists sometimes call the Great Dying, had, not long before this morning, killed more than 90% of all marine species and 70% of all life on land. What remains is a world of survivors, a world still finding its shape, still deciding what comes next, and what comes next turns out to be extraordinary. The creatures of the early Triassic are not the dinosaurs. The great reptiles are still millions of years away from their dominance. What walks across these red plains today are the ancestors, the stepping stones, the trial runs of all the animal forms that will eventually inherit the earth. In the fern scrub near the shallow seasonal river, a group of Lystrosaurus moves slowly. But they are stocky, low-slung creatures about the size of a large dog, with blunt, almost pig-like faces and a pair of small tusks that they use to root in the soil. They are not particularly graceful. They do not command any particular presence. They move with a kind of plodding determination, pulling at tough ferns with broad, horny beaks, chewing slowly, moving on. Lystrosaurus is, in a very real sense, the animal that saved complex life on Earth. When the Permian extinction came, when the volcanoes of what is now Siberia cracked open the sky with ash and carbon and acid rain, when the oceans turned anoxic and the coral reefs dissolved and the forests burned, Lystrosaurus survived. It could burrow underground, sheltering from the worst of the heat and the toxic air. It could go long periods without food. It was tough in the deep, inarticulate way that the most enduring animals always are. Not through cleverness, not through speed, but through a kind of stubborn biological persistence that is perhaps the most fundamental quality of life itself. And so, as you watch them move through the early morning light of Pangea, there is something quietly profound about these squat, unremarkable animals. They are carrying the baton. They are the bridge between the world that was and the world that will be. Every dinosaur, every bird, every mammal, every creature that will ever walk or fly or swim across this planet in the next 250 million years will owe something, indirectly, improbably, but truly, to these slow, wide-bodied animals eating ferns by a dry Triassic river. Further along the riverbank, something else moves, faster, more alert. A small, bipedal creature picking its way between rocks with quick, precise movements. It is an early archosaur, a member of the lineage that will eventually branch into crocodilians on one side and birds and dinosaurs on the other. Right now, it is modest, perhaps a meter long, sharp-eyed and quick. It pauses at the river's edge and drinks with short, rapid dips of its narrow head. It does not yet know what it is becoming. That is perhaps the most extraordinary thing about Pangea. None of its animals have any conception of their own significance. The Lystrosaurus does not know it survived the end of the world. The Archosaur does not know its descendants will rule the earth for 150 million years. The small, furred creature moving in the shadows of the secluded forest does not know that its kind will one day build cities and compose music and stand at the edges of oceans and wonder about the ancient past. They simply live. They eat and drink and shelter and reproduce and die, in the present tense, in this red morning without any knowledge of what they mean, which is, in its way, a kind of freedom. Above the river, the air is alive with the sound of insects, but the insects of Pangea are not so different from insects today. They are among the most conservative animals in evolutionary history, changing their basic forms only reluctantly across hundreds of millions of years. There are giant dragonflies above these waters, their wings catching the early light and scattering it in small prismatic flashes. Beetles, early flies. The air hums with them as the morning warms, a continuous, unself-conscious music that has been playing without pause since before any of the large animals existed. In a shallow bend of the river, a therapsid, a member of the mammal-like reptile group that bridges the deep gap between reptiles and the first true mammals, is half submerged in the cool water. It is a larger animal than the Lystrosaurus, more elongated, but with a longer skull and teeth that are beginning to differentiate in a way that will eventually produce the complex dental patterns of mammals. It lies very still. It might be sleeping. It might be thermoregulating, using the cool river to shed the warmth of its body on a morning that is already beginning to feel the weight of the sun. The sun is climbing now, and the heat, as the sun climbs, is unlike anything in the world you know. Because Pangea has a climate unlike any that has existed since, the supercontinent is simply too big. Coastlines, where the ocean moderates temperature, brings rain, cools the land, are far, far away for anyone living in the interior. The ocean's influence barely penetrates this deep into the continent, and so the interior of Pangea experiences extremes that dwarf anything found on Earth today. The scientists believe that the monsoon system of Pangea was the most powerful that has ever existed on this planet. In one season, winds would draw vast quantities of moisture from Panthalassa deep into the continental interior, producing rains of extraordinary intensity. And then, in the opposite season, the same continent's geometry would reverse the pattern entirely, drawing dry air off the landmass and out to sea, producing months of absolute aridity. Wet and dry, flood and drought, the ancient rhythm of a planet that runs on extremes. But this morning, it is neither extreme. It is simply warm, and golden, and older than imagining. Let us leave the interior now, and travel to the coast. Traveling to the coast of Pangea means traveling for a very long time. The interior of this supercontinent is separated from any ocean by distances that have no modern equivalent. If you stood where Kansas will one day be, the nearest coast of Panthalassa would be further away than New York is from London. The nearest waters of the Tethys Sea would be a journey of comparable magnitude in the other direction. But tonight, we will simply close our eyes and be there, at the edge of Panthalassa, the world ocean, as the morning sun climbs over the water. The coastline of Pangea is unlike any coastline today. In some places it is dramatic, high red cliffs dropping straight into churning surf, where the rock, still warm from the geological activity of the interior, meets the ancient sea with a hiss and a slow, constant spray. The cliffs are deeply layered, each stratum a different color, dark basaltic rock at the base, then red sedimentary layers above, then pale sandy beds, each color a different era compressed into stone. A geologist looking at these cliffs would be able to read the history of the last few 100 million years as clearly as a book. In other places, the coastline is low and wide, vast mud flats stretching for kilometers into shallow water, then shelving down gradually into the deep. These low coastlines are some of the most productive environments on Pangea. Where the land meets the shallow sea, life concentrates in extraordinary density. This morning, we are on one of those wide, shallow stretches. The tide is out, and what it has left behind is a world of small, perfect things. The mud flats glitter in the early light. The surface is textured with the marks of retreating water, ripple patterns that will harden into stone and survive as fossils for hundreds of millions of years. Every pool of water left by the receding tide is a tiny universe, filled with creatures that, while unfamiliar, carry the echo of things you know. Small mollusks with spiral shells that fit neatly in the palm of a hand. Early crustaceans moving with the cautious determination of animals that have learned to distrust the exposed world above the water line. Worm-like animals moving beneath the surface of the mud, leaving trails that will one day be preserved as fossils. Messages in stone to those who come millions of years later and learn to read them. In the shallower waters near the coast, the sea is warm and thick with life. The Permian extinction hit the oceans hardest of all, but even here, in these years of recovery, the sea is beginning to fill again with a biological exuberance that has something triumphant about it. There are sharks in these waters. Ancient sharks, their lineage stretching back hundreds of millions of years before even Pangea existed. The shark is, in many ways, older than the Atlantic Ocean, older than the bones of any continent currently visible above the waves. They move through the warm shallows with the same unhurried precision they will carry into the world you know. The same lateral line sensing the pressure waves of nearby movement. The same ampullae of Lorenzini detecting the faint electrical fields of hidden prey. And they have arrived at a solution so complete that they have barely needed to change in 400 million years. That is not laziness. That is perfection. And in the deeper water, just visible as long, sinuous shapes beyond the murkier zone where the mudflat drops away, something larger, something newer. The first marine reptiles. Animals that had returned to the sea from land, reversing the great migration of their ancestors with a second migration equally momentous. They still breathe air. They surface in long, graceful arcs, fill their lungs with a slow breath, and descend again, trailing a line of silver bubbles. Their limbs are becoming paddles, their bodies streamlining through the patient pressure of selection. They carry in their bones the memory of land, the 5-digit structure, the hip joint, the rib cage, but their lives are entirely of the water. They are the early experiments that will lead, through many iterations, to the great sea reptiles of the Jurassic and Cretaceous, the ichthyosaurs that will grow to 12 meters and move through the open ocean as swiftly and powerfully as any whale. The plesiosaurs with their extraordinary long necks and broad flippers. The mosasaurs that will dominate the warm Cretaceous seas with the casual authority of apex predators who have never been seriously challenged. But all of that is far in the future. Right now, these early marine reptiles are modest, uncertain, still learning the sea, and there is something beautiful about that uncertainty, about the moment before mastery, about the animal in the middle of becoming something, not yet fully there, finding its way by trial and incremental error through a world that is itself still forming. The sea around Pangea carries within it a kind of biological memory that the newer, younger oceans of the modern world do not possess. Panthalassa is vast, far older than the Atlantic, far older than the Indian Ocean. Its deep trenches descend to abyssal depths that have been accumulating sediment since before the continents took their current arrangement. Its mid-ocean ridges are older. The chemistry of its water has been shaped by hundreds of millions of years of volcanic activity, of species evolving and dying and sinking to the bottom, building up layer upon layer of sediment that is itself a record of all the life that has passed through these waters. And in that deep water, far below the reach of sunlight, there is life of an entirely different kind. Slow, patient, unlikely life. Organisms that eat not sunlight but chemical energy, clustered around volcanic vents on the ocean floor where superheated water rich in hydrogen sulfide and dissolved minerals rises from the rock. They have been there since before Pangea. They will be there after it. And they are perhaps the most ancient life on Earth, a living thread connecting the present to the very beginning of biology on this planet. Standing at the coast of Pangea, watching the water, you feel something. It is not nostalgia. It is something older and stranger than nostalgia. It is a kind of recognition, the awareness that the water in front of you is the same water, that it has never left, that the ocean you are looking at will become in time the Pacific, the Atlantic, the Indian Ocean, the Arctic. That the water molecules moving over your feet right now will one day be rain falling on a city that does not yet exist, in a country that has not yet been imagined, in a world that is still several 100 million years from being born. The water is continuous. The ocean never ended. It only changed its shape. You are standing at the beginning of that shape. Pangea is not eternal. Nothing this vast and slow is permanent. Beneath the surface of the supercontinent, the great engine of the Earth is already working. The mantle is convecting. Hot rock rising and spreading and cooling and sinking in enormous, slow loops that take millions of years to complete a single cycle. The heat at the core, produced in part by the slow radioactive decay of elements laid down when this solar system formed, drives those loops continuously, without pause, and has been doing so for billions of years. And where that convecting mantle rises against the underside of the continental crust, it pushes, it weakens the rock, it creates hot spots and flood basalts and rifts, places where the crust is being stretched, thinned, pulled gently but inexorably apart. If you could see the Earth from inside, you would see the stress fractures forming, lines of weakness threading through the rock of Pangea like cracks in old ceramic. You cannot feel them from the surface. The ground beneath your feet today does not shake. The tearing is too slow, too deep, too vast to register on any single morning. An individual animal standing on this plain would live its entire life without detecting the slightest movement of the land beneath it. But it is happening. Over the next 50 million years, a period that is in geological terms relatively brief, Pangea will begin to come apart. Not all at once, not dramatically. It will begin as a narrow rift, a valley, a low place where the land has pulled slightly apart, where water begins to pool in the rainy season, where volcanic rock pushes up through the gap in long, dark flows. And that rift, that first crack in the world, will one day be the Atlantic Ocean. But right now, it is nothing. It is a faint depression in the landscape, a valley no wider than a wide river, in the region that will one day become the eastern coast of North America and the western coast of Africa. Those two coastlines, which fit together like the pieces of a jigsaw puzzle because they were indeed once one, are this morning separated by nothing more than that shallow, warm rift valley. You could walk across it in an afternoon. Imagine that. The entire width of the Atlantic Ocean, 3,000 miles of deep blue water, home to whales and storms and the trade winds and centuries of human history, reduced to an afternoon's walk across a low, warm rift valley, perhaps a kilometer or two wide. Its walls made of fresh, dark basalt, still warm from its recent extrusion. That is the scale of geological time. And it is the scale on which Pangea operates. The rift deepens. Over the next few million years, it will widen. Volcanic activity along the rift will push the two sides further apart. The valley will deepen and broaden. Seawater from the Tethys Sea, the smaller, warmer ocean tucked against the eastern face of Pangea, will eventually spill through a low point in the landscape into the growing gap, and the infant Atlantic will take its first breath. But not today. Today, what will one day be New York and what will one day be Morocco still share the same morning light. The same early archosaurs fly over, both without crossing any sea. The same dust storm that is building on the inland plain will deposit its red ochre sediment on both sides of what is, for now, merely a valley. The rock on both sides is the same rock. You could pick up a stone from the valley floor on one side and carry it to the other, and when the ocean eventually forms between them, both stones will be on different continents, speaking in their mineral structure the same lost language of connection. In the lower-lying areas near the Rift Valley, where moisture collects in the rainy season, there are forests. Not forests like the ones you know. There are no hardwoods here, no flowering trees, and no broad-leafed canopy dappled with autumn color. These are forests of gymnosperms, ancient conifers, cycads, ferns that grow to the height of small trees, horsetails standing at the water's edge like living fossils, even by the standards of Pangea. They are strange and formal-looking, their geometry more architectural than organic, their shadows precise and dark. Walking into one of these forests is like walking into a cathedral built by a civilization that has not yet learned beauty, only structure. The air inside is cool, dim, thick with the smell of resin and damp soil and something faintly sulphurous from the volcanic rock not far below. The sound of the wind disappears here, absorbed by the dense, layered walls of vegetation. The light falls in narrow columns, greenish, filtered, reduced to a kind of perpetual twilight. The deep quiet of the Pangean forest, you stop and listen. There is something moving in the undergrowth. low to the ground, staying in the shadows, moving with a careful, quick-footed delicacy that is completely different from the lumbering plod of the Lystrosaurus, or the broad, heavy presence of the larger therapsids. It is a small animal, furred, warm-blooded. It is a cynodont, one of the most advanced of the mammal-like reptiles, sitting so close to the boundary between therapsid and mammal that the line between them is more a matter of definition than biology. Its body is low and elongated. Its face is longer than a reptile's, with a slightly more complex arrangement of teeth. Different teeth for different purposes are the beginning of the mammalian dental architecture that will eventually allow its descendants to eat almost anything. Its legs are held more directly beneath its body than a typical reptile's, a more efficient arrangement for sustained movement. It watches you for a moment with those wide, bright eyes, and then it is gone, slipping back into the undergrowth, back into the deep Triassic dark, back into the 200 million years it still has to wait before its descendants will stand upright on this land and call it home. The sun is at its height now. On the open plains, nothing moves. This is the deep, burning, windless hour of Pangean midday, when the heat coming off the red soil is so intense that the air above it wavers and blurs and dissolves the horizon into something liquid and unreliable. Even the insects have retreated into whatever shade the scrubby ferns can offer. Even the Lystrosaurus have found the north-facing walls of rocky outcrops and pressed themselves against the cool stone, their round bodies motionless, their breathing slow. Only the wind moves, and today, even the wind has gone. There is an extraordinary silence on the interior plains of Pangea at midday. Modern Earth is rarely this quiet. Even in its most remote places, the deep Sahara, the Antarctic Plateau, at the center of the Tibetan highlands, there is almost always some sound of life. A bird, an insect, the distant rumble of human civilization carried on the upper air. We have filled the world so thoroughly with our presence that even silence in the modern world is rarely complete. But Pangea at midday on a still day, in the deep interior, nothing, just the faint creak of rock expanding in the heat, the occasional dry tick of a pebble settling, and beneath it all, a vast geological silence that is the sound of time itself passing, not quickly, but in the deep, regular pulses of a planet entirely absorbed in its own business, utterly indifferent to any observer. This silence is not empty. It is full of deep time, full of all the life that has lived here and died here and become the rock and the red soil beneath your feet. Full of all the life that has not yet evolved, the birds, the flowers, the mammals, the vast complexity of the modern world still lying coiled and potential in the cells of these first tentative survivors. In this silence, you might think about the continuity of life, about the fact that there is no break, no moment when life stopped and started again. Even through the Permian extinction, even through the most catastrophic mass dying this planet has ever endured, the thread held. It was reduced to something very thin, something you could almost not see from a certain angle, but it was never cut, never fully severed. The Lystrosaurus carried it through the catastrophe. The small cynodonts in the forest carried it. The sharks in the shallow sea carried it. And in the deep water of Panthalassa, in the thermal vents far below the reach of any catastrophe at the surface, the ancient elemental life that predates every animal, every plant, every multicellular organism, carried it through extinction events that it never even registered. In the cool dark at the bottom of the oldest ocean, life is, above all things, persistent. It does not aim. It does not plan. It does not know where it is going, but it holds on, with every chemical trick at its disposal, through every darkness, and it waits for the morning. There is a particular quality to the midday light on Pangea that is worth sitting with for a moment. Because of the extreme clarity of the air in the dry interior, almost no moisture, almost no particulate pollution of any kind, the sunlight that falls on this plane is harder and more direct than sunlight in the modern world. The shadows are sharper. Colors are more saturated. The red of the soil is very red. The pale green of the ferns is very pale, very green. It is a world of high contrast, of strong lines, of a visual clarity that is almost uncomfortable, the way very high-altitude places are in the modern world, where the thin air allows the sun to arrive almost unfiltered. Nothing softens here. Nothing blurs. But in that harshness, there is also a kind of honesty. This is the world before softness, before the cushioning complexity that life will eventually build around itself, before the great flowering plants that will change the visual texture of every landscape, before the grasslands that will carpet entire continents in soft gold, before the deciduous forests that will fill autumn with color. And this world is red and green and white and the deep blue of an unclouded sky. That is all. And it is enough. It is very much enough. The midday silence stretches, and somewhere, very far away, carried on the thin hot air across thousands of kilometers of red plain, there is the faint, imagined sound of a wave. The sea, at the edge of everything. There is a second ocean on Pangea, not as vast as Panthalassa, but warmer, more intimate, more alive. It is called the Tethys Sea. The Tethys occupies the great indentation on the eastern face of Pangea, a wedge-shaped body of warm, shallow water pushing deep into the supercontinent's interior, like a bay the size of a small hemisphere. Its warm, sunlit waters sit at tropical and subtropical latitudes, bathed in more solar energy per square kilometer than almost anywhere else on the planet. After the devastation of the Permian extinction, it is here, in the shallow, clear Tethys, that the great reef systems are slowly beginning to rebuild themselves. The water of the Tethys is extraordinary to look at. It is warm enough to be genuinely tropical, rich, layered blue-greens in the shallows, transitioning to deep sapphire further out where the shelf drops away. Sunlight filters through the shallower zones in long, slow columns, illuminating the sea floor in shifting patterns of gold that rearrange themselves with every small wave at the surface. The visibility is remarkable. In the warm, clear water of the early Tethys, you could see for 30 or 40 meters, watching the world below you play out in a kind of silent, backlit theater. The reefs here are young. They are not the towering, complex structures of a mature reef system. Not yet the Great Barrier Reef or the ancient Permian reefs that preceded them and were destroyed in the catastrophe. The organisms that built the great Permian reefs are mostly gone, or reduced to tiny remnant populations, hiding in deep water, waiting for the ocean to recover enough to support them again. What you are watching in the shallow waters of the Tethys this afternoon is the beginning of a new attempt. New coral species, cautiously expanding outward from their small colonies, testing the temperature of the recovering water. Sponges, the oldest reef builders of all. Organisms whose body plan has barely changed in 600 million years, providing structure and complexity where the corals have not yet reached. And over them, threading between the structures in loose, unhurried clouds of silver and copper and dull gold, the fish. The fish of the tethys are not the fish of today. Many of the modern fish families have not yet evolved. But the fish that are here carry a particular kind of beauty in their primitiveness. There is something honest about their shapes, something not yet refined by the further hundreds of millions of years of pressure and competition and ecological specialization that will eventually produce the explosion of form and color that modern coral reefs display. They are the sketch before the painting, beautiful in their own right, and made more beautiful perhaps by the knowledge of what they are becoming. Above the reef, in the middle column of the tethys, a group of early marine reptiles hangs almost motionless in the blue water, facing into a gentle current. They are resting in the way that large air-breathing ocean animals rest, not truly sleeping, one eye half open, their bodies making small automatic adjustments to maintain depth. They breathe at long intervals, surfacing with a slow, purposeful lift of their heads, exhaling with a quiet sound, drawing in a breath, and descending again. They have been in the water for millions of years now. Their ancestors were fully terrestrial, four-limbed, air-breathing, land-living animals. And then, for reasons that we can only infer from the fossil record, some individuals began spending more and more time in the water, perhaps following prey into the shallows, perhaps finding refuge there from larger predators, perhaps simply discovering, through the long, patient trial and error of evolution, that the water offered something the land could not. And now their descendants are this, creatures that breathe air in a world of water, that carry in their skeletons the unmistakable architecture of a land animal, but whose lives are entirely of the sea. The afternoon light on the tethys is extraordinary. Late afternoon light on water is always extraordinary. That low golden angle of illumination that makes everything slightly more real, slightly more present. On the tethys, in the late afternoon of a Triassic day, that light catches the surface and turns it into something almost too beautiful to describe. A plain of hammered gold, endlessly rearranged by the small waves, stretching from here to the distant shore of a continent that will one day be called India, still locked this afternoon to the great mass of Pangea, its Himalayan roots not yet begun, its monsoon not yet born. The tethys will not survive. As the continents drift, as Africa moves north and India tears free and begins its long journey toward Asia, the tethys will slowly be crushed between the colliding land masses. Now, what remains of it today is trapped in landlocked and semi-landlocked seas, the Caspian, the Black Sea, and, in a more distant ancestral sense, the Mediterranean. The great, shallow warmth of the tethys is mostly gone now. Mostly, but not entirely. You can feel it sometimes on summer evenings on the shores of the Mediterranean, that particular warmth that seems older than the air, older than the rock, that comes up from the deep water with the smell of ancient things. That is the memory of the tethys, the ghost of the world's warmest sea, the great tropical engine of the Mesozoic world, reduced now to a blue remnant between three converging continents. The sun moves lower. The shadows on the Tethyan reef lengthen and deepen into purple and indigo. The colors of the water change from gold to amber, to a deep, transparent green, and then, at the furthest reaches of the visible depth, to a darkness that is not threatening but simply honest. The honest dark of deep water, where no sunlight reaches, where life proceeds by different rules. Evening is coming to the Tethys. Evening is coming to Pangea. The light is changing. Across the interior plains, the merciless white heat of midday has softened into something amber and low-angled and almost gentle. The red soil has turned, in this light, to something approaching gold. The ferns along the river throw long shadows that stretch across the plain like dark fingers. The cycad forests at the edge of the plain are painted in deep, warm ochre. This is the most beautiful hour on Pangea. The animals that spent the day sheltering from the heat begin to move again. The Lystrosaurus groups, heavy and placid, drift toward the water with the unhurried deliberateness of animals that have nowhere urgent to be. A smaller, faster animal, a sphenodontian, an ancestor of today's tuatara, that extraordinary survivor, moves across a flat rock with quick, deliberate steps, its tongue testing the air for the chemical signatures of food. In the fern scrub along the river, something larger is moving with a new kind of intention that is different from the lumbering travel of the therapsids. An early archosaur, more substantial now in the late afternoon than the quick, cautious creature you saw at the water's edge in the morning. This one is bigger, more confident. It stands for a moment in a gap in the vegetation, fully visible, and its body carries a kind of architectural efficiency that the older animal groups lack. Legs held upright beneath the body, neck held in a slight, balanced curve. Eyes forward, predatory. It watches the Lystrosaurus herd for a long time. And then, with a sudden, decisive burst of speed that is genuinely startling, it commits. The ferns close behind it. There is a sound. Brief. A commotion in the vegetation. Then silence. The rest of the Lystrosaurus herd moves on, a little faster for a few minutes, then settling again into their patient, plodding rhythm. This is not cruelty. It is not drama. It is the deep, patient mathematics of an ecosystem rebuilding itself. Who eats, who is eaten, what survives to reproduce, what does not. It is the only language that life speaks in the end. And it is a language so old that it was already ancient when Pangea was young, ancient when the first animals crawled out of the Cambrian seas, ancient when the first cells learned to divide. The sun reaches the horizon, and on Pangea, in the interior, the sunsets are extraordinary. Because of the vast flat plains, because there are no mountain ranges in this part of the continent to interrupt the view, the no forest canopy to reduce the visible sky to a narrow strip, you can see the full, unbroken circle of the horizon. The sun descending into that circle sends its light bouncing across 300 kilometers of flat, reddened land, and the sky above performs a slow, continuous transformation that takes a full hour to complete. First, the orange. A deep, saturated orange at the point of sunset that spreads outward in both directions along the horizon. Then, as the orange climbs, it meets the upper sky and becomes rose, a soft, improbable rose that fills the dome of the sky from the western horizon to almost directly overhead. Then, as the light continues to fail, the colors deepen. The rose darkens toward purple. The east, behind you, is already entering its night blue. a blue so deep and clear that the first stars are becoming visible even before the sun has fully set in the west. And those stars, the stars of Pangea, are the same stars as yours. The constellations are not quite the same. The slow, proper motion of nearby stars across millions of years has shifted their positions slightly, so that Orion would look subtly different to modern eyes, the Big Dipper a little skewed. But the stars themselves are the same burning points of light that your ancestors looked up at, that your children will look up at. The same galactic core arching overhead in a great, luminous band. The same deep, cold infinity. The stars of Pangea look down on a world that has no awareness of them. No animal standing on this plain tonight understands what those lights are. No creature in the Tethys, no archosaur in the forest, no Lystrosaurus at the water's edge has any concept of the scale of what is above them. They live in a world that is entirely immediate, the river, the ferns, the heat of the day releasing into the cool of the evening, the sounds of other animals nearby, the smell of the soil. The universe above them might as well not exist. That is not a sad thought. There is something clean about it, something liberating about a world that is entirely, simply, itself. A world that does not carry the weight of self-awareness. That does not lie awake wondering about its own significance, or the significance of the sky above it, or the significance of the fact that it is alive on a planet in a galaxy that is one of 2 trillion. The temperature drops quickly after dark. Without the moderating presence of the ocean, the interior of Pangea loses its heat rapidly once the sun is gone. Within an hour of sunset, the air has cooled by 10 degrees. Within 2 hours, 15 or more. The animals that were moving in the early evening have slowed again, or found shelter, or turned toward their burrows. And in the darkness, the small mammals are waking. In the darkness, the small warm-blooded animals come alive. This is their world, the night. They move in the shadows with the assurance of animals that have mastered a niche that no one else wants. Their warm blood keeps them moving when the reptiles have slowed and stilled in the cooling air. Their large eyes collect what little light remains from the stars. Their extraordinary hearing maps the darkness around them in real time, detecting the approach of predators long before any visual signal could be useful. They are small. They are cautious. They are, in most objective assessments of the evening's larger fauna, unremarkable. But they will inherit the earth. Not tonight, not for 180 million years. But they are patient. They have been here, in the margins, in the shadows, in the night, since before Pangea began to form. And they will still be here, refined, diversified, quietly extraordinary. When the last of the great Mesozoic reptiles takes its last breath and the long era of mammalian dominance finally begins, they will be there for that morning. And from them, impossibly, improbably, across a chain of evolutionary transformation so intricate and so contingent on chance that the mind struggles to hold it without flinching, there will eventually come a creature that stands upright on 2 legs in the afternoon light of a world with 7 continents and 5 oceans. A creature that looks at a map and notices with a quiet shock that the continents fit together. A creature that picks up a piece of rock and learns to read the time written in its layers. A creature that lies down in the dark and closes its eyes and imagines Pangea. You. Pangea itself will last for another 50 million years after this morning. In those 50 million years, the world will change in ways that even geological time struggles to make comprehensible. The dinosaurs will rise and diversify, filling every ecological niche imaginable. The first flowers will appear, and with them, a new kind of relationship between life and life. The mutualism of pollinator and bloom. The first delicate negotiations between plant and animal that will eventually produce the extraordinary diversity of the flowering world. The continents will drift. The Atlantic will widen from a rift to a river to a sea to an ocean. India will detach from the southern landmass and begin its long, stately northward journey, carrying its cargo of animals and plants toward a collision that will raise the Himalayas and redirect the monsoon and change the climate of the entire northern hemisphere. And with each drift, with each new coastline, each new shallow sea, each new island lifted from the water by the moving plates, life will find new niches, new pressures, new directions. The isolation that drifting creates is one of the great engines of diversity. When two populations are separated by ocean, they diverge. They become different things. They follow different threads of possibility until eventually they are so different that even if the ocean were to close again, they would not recognize each other. This is how the world fills up with difference. This is how one species becomes 10, and 10 become 1,000, and 1,000 become the incomprehensible diversity of the living world we know. 8 million named and unnamed species, and perhaps several hundred times more that we have not yet found, each one a variation on the theme that began here on this red plain in these early mornings of the post-extinction world. It all begins here, on this red plain, on this morning, with Illustrosaurus eating ferns in the early light. Before you drift off tonight, I want to leave you with one thought. Everything you know, every ocean, every mountain range, every continent, every ecosystem, every species, every relationship between predator and prey, between flower and bee, between tree and soil, and the fungi that connect them in the dark, is the child of Pangea, is the consequence of that slow, magnificent breaking apart. The world is made of drift, of separation, of things that were once together and are now spread across the face of the earth, carrying in their rocks and their genomes the faint, beautiful memory of when they were one. The two coastlines that fit together, the related animals on continents that have not touched for 80 million years. The shallow tropical limestone in the Himalayas, a reef that was once at the bottom of the Tethys Sea, now raised to the highest point on Earth by the slow, immovable patience of the moving plates. You are part of that memory. Your atoms were in this soil. Your water was in that sea. The calcium in your bones was laid down in creatures that lived and died in the warm waters of the Tethys, and compacted into limestone, and lifted by tectonics into mountains, and eroded by rivers into the sea, and built into the shells of new creatures, and compacted again, cycling and cycling through deep time in that same patient, unhurried way that the continents themselves move. You are not separate from this story. You are this story. You are what Pangea became. So tonight, as you settle in and let your mind go quiet, let yourself rest in that deep continuity. Let yourself feel the slow, turning patience of the planet beneath you. It has been carrying life for 4 billion years. It carried Pangea. It carried every extinction and every recovery and every bright, improbable morning that followed each catastrophe. It is carrying you now. Let it. Close your eyes. Let the red plains of Pangea fade into the dark behind your eyelids. While at the sound of Panthalassa, that great, ancient, encircling sea, come up slowly, the way a tide comes in, patient and inevitable and warm. You have been part of this planet all along. Good night.